Perfect.
Angel, you have been that laugh all the time. Giggle is phenomenal. Like this form of the breath.
Oh my god.
All right.
All right, let's go ahead and get started. Okay, so last time you guys did exponential functions. Okay, so let me just give you a quick little review. Your parent equation was 2 to the x. And then if you remember, rather than hitting at 0, 0, like almost all of the other parent functions, remember this one starts at 1 box above the origin, and then you double to get the next y values. So 1 would double to 2, that would double to 4, 4 would double to 8. And so essentially what happens is that you end up with an exponential growth graph. Now, as you trace to the left, hopefully you remember it levels off towards 0, but remember it never actually like crosses 0. Okay? So your asymptote, it's an HA at y equals 0. And then remember that what that means is you're going to keep getting closer and closer and closer to 0, but you don't ever actually cross it. Now, last class, we also talked about like how to solve these. We had that little chart, if you remember that. Okay, but for now, that graph should look familiar. What was the domain of this graph? Okay, infinity to infinity, so I'll just put all real numbers. And then for the range, remember you want to do lowest then highest. But what is the lowest that this graph can go since I have that line that I can't cross? 0. And then remember, you'd say 0 is the lowest, infinity is the highest, but I can't get to either one. So to show that I can't like get to 0, I put a parenthesis on it. Okay, so if you know, yes? Left and right, correct. Okay, so the inverse of an exponential, I think this is, y'all have never seen logs before? Have you? I think you haven't. Okay, but the inverse of an exponential is called a logarithm. Okay, so Logarithm. Okay, and what you should remember is that logarithms, they cancel each other out and the x and y's are reversed. So right here it says the domain and range, that's the x's and y's, are reversed. The parent function is going to be y equals log x. And I don't know if you've ever noticed, but on your calculator, you have a log button. That's what this function is. Okay? Now, the one thing that you have to know as well is that normally for the exponential, do you remember how you have a y equals 0 asymptote? Right? Yes? You're going to have a vertical asymptote for the logs at x equals 0. Because remember, x's and y's are reversed. So rather than having a 0 horizontal, you're going to have a 0 vertical. So now, instead of me not being able to touch this line, now I can't touch this line. Okay? Now, the other thing is, do you remember that this point right here is 0, 1? So if I flip that backwards, now it's going to hit at 1, 0. That's right. Okay. And then your graph, as you go down, is going to get really, really, really close to the asymptote. And as you go the other way, it's going to think like it's growing away from the x-axis. Okay. So that's what your logarithm graph is going to look like. Okay, let's talk about domain and range. Domain is left and right. How far to the left can this graph go if it can't cross this line? 0. But it can go to the right to infinity. And I want to point out to you that your domain is your old range. Why? Because the x and the y is flip-flopped, right? Then for my range, I go down forever, up forever. That means it's all real numbers. But my range is now my old domain. Because when you flip-flop the x and y, it's going to flip-flop the domain and range. So your domain and range here are just backwards of the domain and range for the exponential. Okay? So let's do 2 graphs of this just to make sure you have the right idea, and then we'll move on. So take a look at number 1. Your x has a -3 with it. Which way are we shifting? To the right. Very good. And then +2 would be up 2. So go to the right 3, up 2. But then you're going to draw in a vertical asymptote. Like that. And remember, that means you can't touch the 3 line. So your asymptote would be x equals 3. Now for exponentials, I go 1 dot up. For logarithms, I go 1 dot to the side. So I'm going to put my dot right here. And then I'm going to go down and towards, up and away. And that's what your graph would look like. Okay, take a look at number 2. My x has a +5 with it. Which way are we going to go? Okay, to the left 5 and then down 1. So that would be right here. And then remember that that's the point that's going to anchor my asymptote. So I'd go to the left 5 down 1, draw my vertical asymptote. Remember, I can't touch that line, so I'm going to sidestep 1 box and then draw in my little growth. Yes, the only way that you would do it to the left is if you had a negative on the x on the inside, and that won't happen at all. Okay, then your asymptote, what's the x that I can't cross? So x equals -5. Okay. And then if you want to write next to those, remember those are called vertical asymptotes because they're x's you can't cross, versus for the exponentials, they were horizontals that you can't cross. Okay? All right, go ahead and turn the page. So here's the thing with logs. They have some pretty weird properties. There are only 3 of them. Okay, but they're just kind of weird, so just go with it. We're going to do more with logs later this week. But for now, all you have to know is how to use the properties. Okay, so at the top, I'm going to give you the first 2 properties. Okay, the product property says that if you have a log of 2 things that are multiplied, so let's say A times B, you can split them into separate logs using addition. So it would be log A plus log B. If multiplication splits by addition, what do you think division will split by for the quotient? Subtraction. Very good. So your second property is that if it's an A divide by B, you can give them each their own logs if you minus them. Okay? All right, so take a look at number 3. We have the log of 8x. How are 8 and x sharing the log right now? Are they currently multiplied or divided? Okay, this is 8 times x. Then if they're multiplied, when I split them, will I use addition or subtraction?
Or addition. Right?
Addition. So this would go to the log of 8 plus the log of x, and you're done.
Oh.
Okay, it's first day on it, so it shouldn't be too complicated. All right, take a look at number 4. How are the 8 and the x sharing the log? Through multiplication or division? This is 8 divided by x. And if it's 8 divided by x, how can I split them? With subtraction. Very good. So it'd be log 8 minus log x. Everybody good so far? Okay. The last one, you have 3 things. You have a 2, an x, and a y. So we want to break down what the operations are. So this would be 2 times x divided by y. Now remember, all of them want to go to their own log. None of them want to share. So when I break it down, 2 and x will break down with addition or subtraction. But y will get what? Subtraction. So this is going to go to log 2 plus log x minus log y. So easy, good. Light work? Okay, there's only one more property you have to know for today. Okay, the next one is the exponent log property. So here's what the exponent says. If you have the log of a to a power, let's call it n, where n is essentially standing for whatever number exponent you have. You are allowed, only with logs, remember, kind of weird rules, you're allowed to take that n and just move it to the front. So it's going to be n log a. So let me show you what I mean. Okay, this really isn't super hard. It should be pretty easy. Take a look at number 6. I have a 2, an x, and a y. None of them want to share. Right now, are they all multiplied or divided with each other? That's 2 times x times y, 5. So when I split them up, if they're all multiplied, they're going to split with addition. So here's what I'm going to have for my first step. Log 2 plus log x plus log y, 5. Okay, that's using the rules we already covered. Then, using this exponent property, if I have an exponent, I could just drop it down to the front. So which number is an exponent here? And the 5 is going to just drop down to the front of his own log, not all the way to the front, but just to the front of y's log. So here's your final answer. It'll be log 2 plus log x plus 5 log y. And you're done. Okay? All right, 2 more left like that. Number 7, x, y, and z, how are they combined right now? Multiplication. Multiplication splits by addition or subtraction. Which one? So I'm going to do log x3 plus log y plus log z to the 7. That's step 1. Then you're going to take any floating exponents and you're going to pull them to the front of that log. So which numbers are we going to drop? The 3 and the 7. So it'll be 3 log x. Log y will stay the same because it didn't have a floater, and then 7 log z. Okay? Easy? All right, take a look at number 8. I want you to break down the operation. Okay, you have a 2, an a 7, and a b. Everybody gets their own log. anything on the bottom counts as division. So what I want you to write for this is that this is 2 times A3 divided by 7 and divided by B5. And then sometimes people will say, well, wait, aren't the 7 and the B really multiplied? They're multiplied with each other, but they're both divided by the top. So if it's on the bottom, it counts as a division, which means it'll get what? A plus or a minus? Minus, very good. So let's see if we can do this one in just maybe one try instead of having to write it twice. It'll be log 2 plus or minus log A. Plus log A, and then where am I going to put the 3? In the front. So it would have gone here, but I'm dropping it down to the front. Okay, then minus log 7, because that was on the bottom. And then minus log B, but then your 5 is going to need to go in the front. Okay? Do we feel like we can do that? All right, turn the page. You're doing great. Okay, last thing you have to know for this homework is how to convert square roots and cubic roots. So on the next page for number 2, I want you to write at the top, if you have a square root, that is the same as a 1/2 power. If you have a cubic root, which looks just like a square root, but it's going to have a little 3 kind of tucked into the elbow, you're going to turn that into a 1/3 power. So now knowing that, let's do number 10 and see if we kind of get the idea here. How are 7 and square root x combined right now? Are they multiplied or divided? So that's 7 times root x. Then they're each going to get their own logs. They're going to split by addition. So it'll be log 7 plus log root x. And then I would be like, wait, a square root is really the same as what power? A 1/2, right? We put that up here. So you're going to cross out the square root, turn it into a 1/2. And then based on the rule that we just learned, where can we move the 1/2 to?
To the front.
To the front. Very good. So it's going to go right here. So your answer would be log 7 plus 1/2 of a log x. Does that make sense? Okay. All right, let's do number 11. Okay, 15 root A over B3. Let's write the operation first. That's a 15 multiplied by a square root A and divided by a B3. So remember, nobody wants to share a log. So the 15 is going to get its own, A is going to get its own, B is going to get its own. So it'll be log 15 plus or minus log A. Plus, and then plus or minus log B minus. Then after you give everybody their own log, you're looking for floaters. Remember, a square root counts as a floater of what? What fraction? 1/2. Very good. So I'm going to take my 8.5. I'm going to swap the square root out for a 1/2 power, and then I'll drop those down to the front. So your answer, the way you would type it in on Delta Math, would be log 15 plus a 1/2 log A minus, what would happen to the 3? Yeah, just drop it to the front, minus 3 log B. Doing okay on this? All right, take a look at number 12. This time, my square root has a little 3 in the elbow. That makes it a cubic root. So when I break this down, it's a 5 times A squared divided by a cubic root B. And then remember, the reason that matters is multiplied stuff will get a plus, divided stuff will get a minus. So I'll have log 5 plus or minus log A. Plus, and then where will I put the squared? So it'll be like that. Are we okay with that? And then for the b, plus or minus, and it would be log cubic root b, but then I'm going to put a third in front instead. Does that make sense? Okay. So the cubic root and the 1/3, those are the same, and then you pull it down to the front. All right, let's talk about number 13. Am I multiplying or dividing on 13? Okay, it's all multiplication. And if it's all multiplication, then when I split it, it's going to go to all addition. So I'm going to have a log 10 plus a log square root x5 plus a log cubic root y4. Okay, so write that first. That's just a test in case you're concerned. It's just the first Wednesday of the month. Okay, so I have a square root. What power does this square root turn into? A half. Now, what if I already have a 5 in that spot? Then here's what you're going to do. You're going to still cross out the square root, but you're going to just cut the 5 in half. So it's going to go like this. Now it's 5 halves. Fine. I think Delta Math will still count that. Okay, then for your third root, what does that mean I need to do for my fraction? A 1/3, but I'm putting it on the 4, so it'd go to a 4/3. That's correct. Okay, then once you have those fractions, drop them down to the front. And then chi, since that one would go to 1.333, you'd have to fraction it. Okay, so then these guys will just drop to here. Okay, when I say drop though, remember they're only dropping to the front of their own log. They're not dropping way, way, way to the front, just of their own log. So you'd have log 10 plus 5 halves log x plus 4/3 log y. Good? All right, let's do the next one. First question, what's the operation on the inside? Multiplication or division? Okay, all multiply means all plus. So I'm going to have log 2 plus log c plus log d to the 4. Okay, but all of those were inside a what? Then a cubic root is the same as what power? A third, then I'm going to have to put the third on everybody that was inside it. And then remember, if the D already has a 4, I have to third what's already there. And then from there, just drop them down to the front like we've been doing. So it'd be a third log 2 plus a third log c plus 4/3 log d. Okay? Can we do that? All right, so on a normal day, I would do half the homework and then come back to the notes. But since this is maybe a little easy, could we just finish the last page and then be done? Okay, so everything you just did is expanding. The reason it's expanding is you're starting with 1 log, and then you're splitting into everybody having their own. Turn the page. And we're going to learn how to condense logs. Okay, so the first half of your homework, you already know how to do. So now turn to the last page. Okay, if you have multiple logs, you're going to do the exact same rules, but backwards.
Okay.
Okay, so if you have a number in the front, you're going to pull that number back up. And notice, you already know how to do that rule. You're just now going in the opposite direction. So condensing, you're trying to squish everybody into having to share the same log. If I have a log A and a log B that are added, how will I get them to share the same log? Multiplication or division? So I'll do A times B and they can share. And then what if my log A and log B are subtracted? How will I squish them back together in the same one? Divide. But remember, it's the exact same rules. The only difference is that now, rather than splitting everybody up into their own, you're squishing them back together into the same. Okay, so let's start with number 1. What front number can I pull back up as a floater? The 7. So cross the 7 out, pull it up. Then from there, my log 3 and my log x7 are added. How will I pull them back together? I'll multiply. And then 3 times x to the 7 would be log 3x7. And that's your answer. Okay, take a look at the next one. Do I have any numbers to pull up? The 2's already in the log. What about the 5? So cross it out, make it an x to the 5. And then if log 2 and log x5 are added, I'm going to put them back together with multiplication. So it'd be a 2x5. Yep. All right, take a look at number 3. Number 3 is similar. Okay, I have a 5 in the front, but it's with a y minus 3. So when you cross the 5 out, you're going to apply it to the y minus 3 together as a group. Are you turning something in?
Yeah.
That's okay. Don't worry about it. You just need to check. It's probably, were you unable to bubble?
Oh, yeah.
So I'm going to let you bubble it tomorrow.
Oh, okay.
But y'all's class had the weird issue. Yeah. All right. Then what other number can pull up?
10.
10, thank you. Okay. So then we have a 14, an x10, and a y minus 3 to the 5. When we pull them back into the same log, you have to be careful. Pluses get multiplied, minuses get divided. So it's going to be log 1 big fraction. The 14 and the x10 will be multiplied. But the y minus 3 to the 5th will have to go on the bottom. Okay, because it was a minus on the 3rd log, that one needs to be divided on the fraction. Okay? Good? All right, take a look at number 4. If you have parentheses, okay, you have to eliminate the parentheses before you move stuff. So I'm going to take this minus from the front, and I'm going to multiply it into both of these logs. All right, we're almost done, guys. We're almost done. So your log x is going to stay the same. Okay, ladies. Okay, so we're going to take our minus. We're going to apply it to the 5 log A. And then we're going to minus on the minus 3, which is going to turn it to a what? Minus 3 would be plus 3. Okay, then now that you have distributed that subtraction into these parentheses, now you can pull your numbers up and then pull everybody into the same log. Okay, but you have to eliminate any parentheses from your equation before you do that. So my 5 is going to pull up, my 3 is going to pull up. And then who's going to end up in the bottom of the final fraction? The x, the a, or the b? The x. No, not the x.
Oh, no.
Who's subtracted? The a. So it should be x. A5 has to go down. B3 will stay up. Okay. Now, originally, the B would have looked like it was going to go on the bottom, but because the minus and negative switched it to a plus, that's why it gets to stay on top. All right, one more left like that. Take a look at number 5. We have a 4 outside of our parentheses. We're going to have to distribute that in to both logs. So my first log x plus 1 is now a 4 log x plus 1. What about my 4 times my 8 in the front? 32 log y. Now, will I also times the 4 by the minus 2 on the third log? No, because the parentheses only group the 4 with the first 2. So then this is going to stay a minus 2 log z minus 10. Okay, then from there, I'm going to pull those front numbers up, then pull everybody into the same log. So my 4 is going to go here. My 32 is going to go here. My 2 is going to go here. And then when I condense, which letter is going to end up on the bottom? The X's, the Y's, or the Z's? The Z, because the Z has a what in front? Subtraction. So it'd be log, big fraction. We're going to have an X plus 1 to the 4th on top, a Y to the 32 on top, and a Z minus 10 squared on bottom. So distribute to eliminate any extra parentheses first, pull your front numbers up, and then squish everybody back together. All right, last 2 examples, almost done. Okay, if you have a number on the outside, we know we're going to distribute that. This time our number is a fraction. Okay, but that's okay, we can do it. What is half times a 6 in front? 3 log A. And then for the second term, for my log B, if it didn't have a number in front, then I'm just going to bring that half into the front. So it'd be a half log B minus 7. Okay, once those extra brackets are gone, we're going to pull our front numbers up, then combine everybody back together into the same log. So my 3 goes up as an A cubed. My half goes up on the B minus 7. Hi, thank you. And then from there, oh, Molly's not here today. You want this back? Thanks. So I'll have log A, 3, and then B minus 7 to the half. Now, delta math is going to count that wrong because what is a half the same as? Okay, it is the same as 0.5. What symbol?
Square root. Oh, so yeah.
Yeah, so this should be log A3 square root B minus.
When you get a chance, can you tell us until I made it?
Yeah, remind me, we're on the last example, and I'll do it in a sec. All right, last one, number 10. I have a number outside of a parentheses. That means I need to distribute that number into both of the numbers in the parentheses. A half means divide by 2. What does a third mean? So if I do a third on a 12, what is that now? 4 log A. And then for my log B, if it doesn't have a number, that means I just put the third in front. So it'd be a third log B. Will I continue to distribute that into the last log? No, because if the parentheses are over, then I can just leave it. Then from there, we'll pull those front numbers back up. So this is now an A to the power of 4, a B to the power of a third, and a C to the power of a half. When we put them back into the same log, which letters, multiple letters, will end up on the bottom? A, B, or C? B and C will both end up on the bottom because they both had a minus. So you'll have log big fraction. Only my A4 gets to live on top. And then my third will turn into a what around the B? Cubic root of B. And my half on the C will turn into a square root of C. So it would be like that. Does that make sense? Yeah. Okay, so the first half of the homework, you're breaking them down into individual logs. Second half of the homework, you're putting them back together. Okay? All right, if you want scratch paper, I'll bring you some. Okay? You can do it.
Oh, what is it?
Amari, I'm gonna take my seat back.